So let's continue on talking about our different groups. So let's talk about halogens. So remember, this isn't the very last group. This isn't 8A. This is 7A. So the second to last group on the right. So my halogens is group 7A. These are nonmetals because they don't specifically have it in the name, where the other two have metals in their name, so it kind of helps it. These don't have metals in their name, they're nonmetals. And remember, we can find nonmetals in all three states, but in halogens alone, we can actually find it in all three states. So it's kind of cool. So these two, fluorine and chlorine, we like to find them as gases. Bromine likes to be a liquid. And iodine and acetylene like to be solids. So as I'm looking in just one group alone, I've got all three states. I've got gases, liquids, and solids. These are all what we call diatomic. So they're all what we call diatomic. What that means is you're not going to find just F chilling by himself. He wants to be diatomic. Di meaning two, and atom, two atoms. So in nature, what we find is it's going to be F2. So he wants two of his atoms together by himself. Chlorine, Cl2, Br2. So in nature, if we were talking about fluorine, we would know, because it's diatomic, that we're talking about F2, not just F. And we'll talk about being diatomic a lot more later. These guys are very reactive, and they're going to react with metals. So they're going to react mainly with our group 1 and our group 2 that we've already talked about. All right, so those are the halogens. So next, let's move from group 7A to group 8A. And I have some pictures here. Chlorine, so you can see like chlorine gas, which isn't very good for you at all. It's kind of got a yellow hint to it. Iodine, so it's kind of these purple crystals, but what happens is they sublime really easily. So what that means is they go from a solid to a gas really easily, and so you can use this to dye things. So that's what those two look like. All right, noble gases. So this is our last one. This is group 8A. Hence the name noble gases. These are all gases at room temperature. Okay? So these are going to be all gases at room temperature. These guys have very low melting and boiling points. Now, the other part of their name, gases tell you that it's a gas, but the noble part tells you most of the time, if you think about like nobility, they kind of don't want to mix with other people. They don't like to be like reacting with other people. They're kind of, want to be by themselves. So the reason they're called noble gases is because this whole group, these guys are very unreactive. They don't want to mix with anybody else. Okay? You might be able to like put some of the gases of themselves together, but then they just kind of like mix around. They don't even react. They just stay kind of in like the balloon or whatever together, but they don't actually react together. So these guys are very unreactive. They're also, they don't want you to mess with them. They don't want to mess with other elements, but they also don't want you to mess with them in the sense of removing or gaining electrons. So it is very hard to remove or give an electron. Okay? So these guys, they don't want you to react with anybody else, and they don't want to make either a cation or an anion. They don't want to be messed with at all. Just leave them alone. So some examples of these noble gases are helium. So remember, those are usually put in the balloons that keep them floating. Neon, those are the things that you see in your little neon lights, but remember, not all neon lights are made with neon. You got argon, krypton, and xenon. Okay? So those are our noble gases. Those are our trends as far as our groups are called. Now we're going to transition into our next trend. Our next trend is going to be looking at the periodic table and predicting what charge an element would like to have. Is it going to be positive, negative, and then what number, what are we, +1, +2, -1, or -2 that it would like to have.